Hello and welcome. Today we're going to look at the SQ4R strategy, specifically with two-dimensional momentum. So the objectives for today is we're going to learn how to apply the SQ4R strategy. We're going to define what linear momentum is. We're going to state and apply the principle of conservation of momentum to collisions in one and in two dimensions. We're going to relate force to the rate of change of momentum. And we're going to discuss energy changes in perfectly elastic and inelastic collisions. Okay, so what is the SQ4R strategy? It's a S, a Q, and 4Rs, and the symbol letters stand for surveying, questioning, reading, retrieving, recording, and rehearsing. Today we will be looking at the first three: survey, question, and read. So the purpose of surveying is to get the big picture of what the content is about. Then we move over to questioning. The purpose of questioning is turning the content into questions. Okay, that is an excellent way for deep processing to take place, and we are curious by nature. So the moment we start asking questions about the content, when we read specifically for the answers of those questions. So the purpose of reading is to engage actively and to read the text to gain meaning, not just to skim through or to passively glance over. So now when we're reading, we're actually looking for answers to questions that we developed ourselves. Then from there we go to retrieving. The purpose of this is to retrieve answers from working memory. So this we would most probably use a probe for gaps questionnaire or something like that. And whenever we cannot retrieve from memory, we have to go back and reread. Once we've successfully retrieved the information and reread until we've retrieved all of it, we can go over to recording phase, where we record the content in your own words and in an organized, systematic way. Last but not least, we're going to go to rehearsing, where we're going to look at a few past paper questions in different difficulty levels. And the purpose of this step is to stimulate deep processing by critically probing for gaps. Okay, so we're going to look at surveying, and I'm going to demonstrate to you guys how I want you to do it. Firstly, I've given you a page like this with about momentum. We're going to look at headings, subheadings, pictures, words in bold, and side notes. So if we look on page 86 and 87, I want you guys to look for any headings, okay? And we know the heading of the chapter is called momentum. Then we look for subheadings, and subheadings we've got the idea of momentum, modeling collisions, and defining linear momentum, and write them down. Then we go to pictures, and we look at all the inscriptions of the pictures, and we write them down, okay? And then we look for words in bold. Now in this section there's only one word in bold, but we also add the definition and the formula. Okay, so we put that there, and any side notes, this green part here about understanding collisions, can be considered as a side note. Now you have to try. I want you to take page 93 to 97, and I've given you a section on 2D momentum and Newton's laws, and I want you to write down the headings, the subheadings, the pictures, the side notes, and the words in bold. Now, once we've finished that, we're going to go over to the questioning. I'm going to demonstrate to you. So this is what I wrote down for my surveying, and now we're going to turn all of this into questions. So momentum, the heading momentum, we can ask what is momentum. Subheading, the idea of momentum, we can ask how should I think about momentum. Modeling collisions, how can I model a collision. Defining linear momentum, what is linear momentum. And then from the heading, the pictures, we can turn them also into questions. How is momentum connected to collisions? How can we use the laws of physics to predict the motion of pool balls? Okay, how does head-on collisions transfer energy or transfer momentum? How does a collision where the balls stick together affect the momentum? Okay, and then the words in bold, what is linear momentum, specifically the linear part? What is the unit for momentum? Okay, what does the P stand for? And then on the side note, when the understanding collisions, if you read there, how can force acting on the driver be reduced during a collision. So I've now taken my survey, I've turned it into questions, and I want now for you to try as well. So go and take your 2D momentum section, take your momentum and Newton's law section, turn them into questions on the next sheet, and then yeah, you're going to submit that to me. And then we're going to go to reading. Now the demonstration is as follows. We're going to take the first question, and how should I think about momentum? And then I'm going to go and read through the pages, and as I read, I've got this question at the back of my mind: how should I think about momentum? And that's how we would go through it until we've answered all the questions. We don't record it yet. That's the next phase. So we just read for understanding and to answer the questions that we've written down in our head. Okay, and we'll stop there. Have a nice day. If you've got any questions, please let me know.